Lesson 95, variables on both sides. Some equations have a variable not just on one side, but on both sides. To solve these equations, we gotta first add as necessary to eliminate the variable on one side so that it's only on the one other side the way we're used to. For example, 3x plus 3 equals x minus 5. X on one side and on the other, what am I going to do? Because I know I need to get x by itself, but on one side, all by itself. Give it a try. It said we're going to need to add as necessary, but I'm going to tell you right now, typical adding is not going to help us solve this problem. So is the book lying to us? Not so much, because remember, adding can sometimes seem a lot like subtraction. In what way? Algebraic addition can mean adding a negative number, which will take away either side we choose. Which side would you like to take the x away from? You may not have a preference. I do. Maybe you'll figure out as we go along why I say go with this one. And do the same on both sides, canceling out your x on one side. And how many x's do I have over here? Don't forget your 3. Now I've got x on only one side, and that's the point. We need to get it so that eventually I'm only doing x equals on one side, and I'm not trying to, play a balancing act on both sides of the equal sign. What to do next? Add a negative 3 to both sides. You show it that way to remember. Everything's kind of algebraic addition, and then the negative sign stays with the 3. Cancel out 2x equals, you probably hate this, and 2x needs to be divided by 2 so as to cancel out the 2's, which creates a 1x, which of course we can just say forget about it. And on the other side, our final answer, positive or negative? Hope you're thinking negative. How'd you do? See that coming? Yawning yet? I hope this is easy. Next example you'll find on page 296, if you want to follow along in your book, up to you, is 4x minus 2 equals a negative x. Are you scared by the negative x? It said add as necessary so as to get x by itself on one side. Well, in this case, we don't even have to add a negative. We're just adding 1x. Do the same to both sides. It needs to stay equal and balanced. See what happened by doing it that way? Then we end up with nothing over here. And we've got just 5x minus 2, which is fine. I think I can solve this problem by adding a 2 to both sides. And now problem solved. But in general, it's good to just avoid letting that ever happen. The book will never want you to do that. So if we go back, how could I have solved that from ever happening where we have a question mark hanging out by itself? Subtract the 4x from this side. Even though we still have a negative x, and I don't like that, it's better than having a question mark and risking getting confused. What do I have over here? Negative 1 minus 4 is. Now, everything is negative, sure. But in case you haven't figured it out yet, you can go like this as long as you do it to the other side. Next. What's my step? Either divide by 5, both sides, or you can think of it as, some of you like to think of it as, multiply by a 1 over 5. 1 over 5. So as to cancel that out. Of course, that's technically canceling out. I got x by itself on the right side. Again, not my favorite side, but whatever. 2 times 1/5, 2 fifths. What do you think? Are you still with me? Can you do one more? Hardest one yet. Negative 2x plus 9 equals x plus 4. Let's get it on. Here we go. What do I do? What do I do? What do I do? Add is necessary to get x by itself on either side. Which one's the better side to get rid of? I'm a fan of removing negative numbers anytime I can. I don't like them. So, of course, the 4 is still over here. It's not like terms with this. But what about... how many x's? What's next? I've only got one x on one side. That's a plus. Add -4 to both sides, right? Ugly problem. Sometimes they are. Sometimes you just have to trust your instinct. 13 thirds is x. How can I check this problem, by the way? Well, I can take 13 thirds and pull it on up, place it here and here, and I guarantee it'll come out with an equal amount on both sides. I'm not going to go through that, but it will. It will. I need work and answers for both practice problems on page 297, and good luck with the problem set. Thank you.